This video is for 3.4 Exponents and Division. Okay, when we start, we are looking at that exponents allow you to write your expressions containing repeated multiplication more efficiently and precisely. So here we have 7 to the 8th divided by 7 to the 3rd. I know it looks like a fraction, but it's really divided by, and here you notice that we have the exact same base. So with that, 7 to the 8th really means 7 8 times, and 7 to the 3rd really means 7 3 times. So we're going to go ahead and we're going to cancel out all of them that we can. So here we're canceling out each one. We've canceled out 3 on top, 3 on bottom. And then we're going to take a look at what's left. Well, what's left is 5 sevens. So we have 7 to the 8th divided by 7 to the 3rd, and we are left with 5 or 7 to the 5th power. We just came from learning that one base with an exponent times one base with an exponent. We're going to take and keep that same base, and we are going to add our exponent. So here we have 7 to the 3rd times 7 to the 4th. And remember, that means 7 times 7, 3 times, and 7 4 times, and that gives us 7 to the 7th power. Okay, here we're looking at 7 to the 8th divided by 7 to the 3rd. And you notice that instead of adding, which is what we were doing here, 3 plus 4, we're going to be subtracting. So we have 8 minus 3. So just like we have addition, which is complementary to multiplication, we have subtraction, which is complementary to division. So when you are seeing that we're dividing bases with exponents, we're going to subtract those exponents. This is going to be true whether we are looking at numbers or if we're looking at letters. Either one, we're going to do the same thing. Okay, so let's try some examples. Okay, on our first one, we have 10 eighths divided by 7 eighths. So both times we have the exact same base, so we're going to take 10 minus 7 and get 3. For the second one, we have y to the 13th over y to the 9th, so we're dividing them. So we're going to take 13 minus 9, and we're going to keep our y, so we have y to the 4th. On our last one, we have d to the 20th divided by d to the 13th. So I'm going to do 20 minus 13, and that's d to the 7th. Go ahead and give this one a try. You can press pause, see if you can come up with the right answer. Okay, so as we're working through it, we have g, and we have 35 minus 23. And so as we're looking at that, because we're subtracting them, the only one that's going to make sense is A. Does a to the 12th divided by a to the 8th have the same value as a to the 6th divided by a squared? And they want us to justify our answer. So we know we're going to take a, and we're going to do 12 minus 8, which is a to the 4th. And we have a to the 6th minus 2, and so we have a to the 4th. So yes, in fact, they do equal each other. Some expressions are going to contain exponents with different bases. So we need to take a quick look and see how we will work through this. So we have 3 fifths to the 4th power, which really means 3 fifths times itself 4 times. So we're going to multiply. When we multiply fractions, we just multiply going straight across. So we have 3 times 3 times 3 times 3, or 3 4 times. And the same thing is true with the bottom. So we're going to have 5 times itself 4 times. So once we have it here, we can go ahead and we can simplify it. Since we have both numbers, if we were to have a number and a letter, we would not be able to simplify it. Let's look at another way to do it. Both of these bases have 1 next to them. So we have 3 to the first power over 5 to the first power, and that all being multiplied by 4. Now, just like we did before with our powers to the base, or our bases with the powers, we're going to go ahead and we're going to multiply them here. So I have 3 to the fourth power, and then I have 4 times this one, which is 5 to the fourth power. And then once again, we can go ahead and multiply them out. So in this case, I'm going to get 81, and then I'm going to have 5 to the fourth power, which is 625. And then we could reduce if we had anything that we knew for sure could go into both of those. And then you're going to do the same thing whether you are doing it with numbers or with letters. They have given us 2 expressions to simplify, so let's go ahead and do that. So I have a to the 7th over 5, which we know really means 5 to the first power, and that all to the third power. So I'm going to go ahead and multiply the a to the 7th 3 times. So that's going to give me 21 a's. And I'm going to say, okay, now I'm also going to have 5 3 different times. Because I can't do anything with the a to the 21st, I'm going to go ahead and leave that. But I know that 5 times 5 is 25, and times another 5 is 125. So this is going to be it fully reduced. Okay, so let's take a look at our other one. I have 2x to the third power over 3y. And we're going to multiply all of that times itself. So here I'm going to do 2 times the 1. And so 2 times 2 is going to be 4, so I can go ahead and do that one quickly. Then I'm going to keep my base of the x, and I'm going to say 2 to the third power times 2, or to the second power is going to be x to the 6th, divided by 3 to the first power squared times y to the first power squared. So with this, I'm going to have 4 x to the 6th, and then I'm going to have 9y squared. Now I can't reduce anything because I have different bases. So this is as far as I can go. Go ahead and try this one on your own. You have your 4 answer choices and the expression to simplify. So go ahead and hit pause and see if you can work through this one. The tough thing on this one is to make sure that you are going to distribute that 4 to every single base. So we're looking at the bases, not the exponents. So I have a squared times 4, which is going to be a to the 8th. Then I'm going to take this 4 and I'm going to multiply it by this 1 down here. So I have 4 to the 4th power. And then I'm going to have the base of 3, or of b, and then I have 3 times 4, which is 12. As I'm looking through, I'm going to go ahead and multiply my 4 times itself 4 times, and I'm going to get 256. So this is 256, and I have b to the 12th, and I'm going to keep my a to the 8th on top. So this is final answer, which is also right here. Okay, go ahead and make sure that you're writing any questions down so you can check in with me tomorrow, and I will see you then. Thank you. Have a good night.